How's it going, everyone? In today's video, we are going to be reviewing Unit 1 on number properties. The first half of Unit 1 is all about exponents. So this little chart right here goes through and lists out all of the properties of exponents. If you don't already have a copy of this, you can access it from the class notes, or of course, you can pause the video and take a little screenshot of it. All right, let's go ahead and get started with our review problems. Question number 1 says simplify the expression completely. Do not leave your answer in exponential form. All right, so I'm going to need to make sure to remember that and go back and double check those directions when I'm all done. But I'm going to go ahead and first use the property of exponents to simplify, then I can do that extra step. When I look at this, I notice that my two powers are being multiplied here. We have 4 to the 4th being multiplied by 4 to the 5th. Since our powers are being multiplied, I can use the product property. And the product property tells us that if we are multiplying two powers with the same base, and these numbers both have a 4 as the base, we can add the exponents. So 4 plus 5 would be 9. We have 4 to the 9th. Now, this is where a little discretion is involved. If your answer was a really small exponent, like 4 to the 2nd or 4 to the 3rd, then that's something that I would want you to go ahead and work out either in your head or on paper. But when our exponents get really large like this, 4 to the 9th, that's going to be a really big number. You do have permission to use a calculator on that problem. So go ahead, pull out your calculator, make sure you know how to use it properly. And what is 4 to the 9th power? All right, hopefully that gave you a second to work that out. 4 to the 9th is 262,144. So even though both of these answers here are equivalent, 4 to the 9th and the 262,144, they're both equivalent answers. Because our directions told us to simplify completely and not leave our answer in exponential form, that's why we needed to do that extra step. All right, let's go ahead and look at number 2. We are being asked to simplify the expression. So very similar to earlier, only this time we don't have to simplify it completely. We just need to simplify it as much as possible. We have 3y to the 8th times negative 2y to the 3rd. Once again, we're going to be using that product property because we are multiplying. We have both a mixture of coefficients, so our 3 and our negative 2, and we have a power, and in this case, our power is a variable. So when this happens, when you have two coefficients that don't have an exponent greater than 1, our 3 and our negative 2, we can just multiply those like normal. So 3 times negative 2 would be negative 6. Then with our powers, our y to the 8th and y to the 3rd, because they're a power, we can use our property of exponents, which says because they have the same base, we can add the exponents together. 8 plus 3 is 11. And that is as simplified as I can make it because I'm not given any information as to what our value of y is. All right, let's check out a couple more. Question 3, simplify the expression. And here we have 5 to the 7th times 5 to the 4th, all over, or another way of saying that is all divided by 5 to the 3rd. This is a case where we have multiple properties of exponents that we want to use. We want to take it back in our thinking to order of operations. That always guides us when we're trying to figure out the order of which to simplify something. And the very first thing in order of operations is P for parentheses. Now that parentheses is a little misleading because it actually means any type of grouping symbol. So that could be parentheses around a group of objects. It could be brackets, or it could be what we see right here, and that is a fraction bar. Our numerator is one group and our denominator is a group. So we need to make sure the numerator and denominator are simplified before we can use that quotient property of exponents. So up top, we have 5 to the 7th times 5 to the 4th. That product property tells us we can add our exponents. 7 plus 4 is 11. And all of that is divided by 5 to the 3rd. Now that it is simplified, we can use the quotient property, which tells us we have two bases that are alike. They both have a 5 as a base, and they're being divided. We subtract the exponents. 11 minus 3 is 8. And it doesn't tell us to simplify it completely. It doesn't tell us to write our answer in standard form. Therefore, 5 to the 8th is the acceptable answer. All right, number 4. Simplify the expression 4 times x to the negative 2. When I look at this, it doesn't immediately hit me if there needs to be anything to be done. We don't have any multiplication going on. We don't have any parentheses with a power to a power. We don't have any division. But don't forget that when you are working with exponential expressions, as we have here, in order for something to be simplified, our exponent cannot be negative. The property with negative exponents tells us that whatever has the negative exponent, if we move it to the other side of the fraction, it changes its sign. So the first thing we want to do is we want to rewrite this as a fraction. Anything can be rewritten as a fraction by putting it over 1. Now, what is all going to go down into the denominator? Only the base and its attached negative exponent. That 4 is separate. That 4 is being multiplied. That 4 does not have a negative exponent. Therefore, it stays in the numerator. But our x to the negative 2 power is going to go down into the denominator. And when it changes sides, it has a positive exponent. And for the purposes of where we are at in regards to our math courses, this is our final answer. We don't have any negative exponents, therefore we have simplified it. All right, let's try one more example with exponents. We want to select all of the equivalent expressions. Keyword there is select all equivalent, so equal expressions. Even though I know that means there's going to be multiple answers, I like to go ahead and just start solving this, and as I go through each step, I check the answer choices to see if any of them match up. First thing I see here is we have the power to a power property because we have 3 squared, which is a power, and that is being raised to another power, that negative 4, power to a power. Meaning to simplify this, we will multiply the exponents. So 2 times negative 4 would be negative 8. I did the first step. I know I'm not done, but because I want all equivalent, I'm going to pause and look and see if any of these answer choices say 3 to the negative 8. And looky there, one does. So that is one equivalent expression. All right, let's keep going. Because as we talked about in the previous question, we can't leave our answer with a negative exponent. We need to rewrite this as a fraction, and then that can go down into the denominator and it becomes positive, but can we leave the numerator blank? Nope. So we need a 1 up there because if you multiply something by 1, it doesn't change its value. How about, does that show up in our answer choices? Yeah, right here. That's also a possible answer. Well, let's now look at my answer choices because that's all I think of to do at the moment. Well, 3 to the negative 2, it's not going to work because I already had a 3 to the negative 8. 1 over 9, oh, maybe. Those two we said, 1 over 3 squared, nope, because it's 1 over 3 to the 8th. So both of those don't work. and then 1 over 6,561. Well, with the two remaining choices, it looks like they went ahead and completely simplified the numerator to come up with an equivalent expression. So this is another one that's a little bit larger. We do have permission to use a calculator because it's not just 3 squared or 3 to the third. So 3 to the 8th power is 1 over 6,561, giving us our final equivalent expression. The second half of our Unit 1 was all about scientific notation. So before we head into that, this poster doesn't include all of the operations, but it is a really nice intro on the basics of scientific notation. So if this is something you need and you don't already have a copy from the class notes, pause the video, take that little screenshot. All right, we're going to start with conversions. So question 6. Convert the number into scientific notation. Well, if we think back to that prior slide, that you should also have a copy of in your notes, in order for something to be written in scientific notation, our coefficient needs to be a number that is greater than or equal to 1, but less than 10. And if I look at this decimal number here, that is definitely not greater than or equal to 1. Therefore, to convert this into scientific notation, I need to see how many times that decimal point should be moved. So we are moving that decimal point 1, 2, 3, still not far enough, 4, 5, almost, 6 places. So I had to move that up 6 places in order for my number to be a 6. The rest of that for scientific notation is we have times 10, because the base of 10 is the number system that we work in, tens, hundreds, thousands, and so on. And then remember in scientific notation that our exponents have a special meaning. They don't mean what they usually do in the rest of math. In scientific notation, it's like this special little subset, and that exponent identifies for us how many times that decimal point was moved in order for us to write it in this abbreviated version, this shorthand, this scientific notation. Well, we already determined that we moved it 6 times. The next piece is, should that 6 be a positive or a negative 6? It should be a negative 6 for 2 reasons. One way that you can recognize is whenever we have a number with a really small value. So this number is less than 1, it has a tiny value, it has a negative exponent. Another way is because we had to undo all of those decimal points, we had to move it to the right, we're undoing them. That causes us to have that negative exponent. There we have the equivalent. These numbers are equivalent. They're the same thing, just one is in standard form. The other one, which is what we were asked to do, is in scientific notation. Number 7, same directions, only this time we have a number that is significantly larger than 1. And our restriction on that side is our coefficient, in order for it to be in scientific notation, has to be less than 10. So in this case, we don't see a decimal point. Well, if you don't have any numbers to the right of a decimal point other than 0, we don't usually include it. But if we include that in, we're going to now need to this time move our decimal point to the left so we can make our number smaller. And we need to keep going until we get a number that is less than 10. We're moving it 1, 2, 3, 4, 5 times. So I've moved it 5 times. And if I stop right there, our number becomes 54. But that's not less than 10, so I need to move it again. Just so happens to be 6 times. Clearly, that's just how many zeros I wanted to include when I created this. I promise it won't always be 6 movements. And now our number is 5 4/10, and then once it turns to all zeros, we don't need to include those anymore when it's written in scientific notation. and then times 10 to the what? Well, just like before, there's two ways you can think of this. We know that our exponent needs to be a 6 because that's how many times our decimal point was moved. But should it be a positive or a negative 6? One way to look at it is we started off with a really large number, really large in its amount and its value, which gives us a positive exponent. And also because we moved it to the left, we are adding decimal point movements. It will be a positive 6. All right, let's try some conversions where we go the other direction. So for 8 and 9 here, we are going to convert our number into standard notation. All right, for our number 8, we have 4 and 89 hundredths times 10 to the 4th. First off, I'm going to rewrite just the 4 and 89 hundredths so I can have some space to work. And then I notice that my exponent is a positive 4. That means that I need to move my decimal point 4 times. And if it's a positive 4, this number started off as a large number. It needs to be greater than 10. Therefore, if I need this number to be greater, I'm going to want to move my decimal point to the left to undo that scientific notation and create a larger number. We're going to move it 1, 2, 3, 4 places to the left. And then any space where we passed our numbers is filled in with zeros. Our number in standard notation is 48900, otherwise known as 48,900. Question 9. We want to convert this number to standard notation, 9 times 10 to the negative 7th. I'm going to rewrite that coefficient up front, and I notice that my 9 doesn't have a decimal point. I'm going to go ahead and add 1. And my exponent in this case is a negative 7. That tells me two things. One, I need to move my decimal point 7 places. And because it's negative, this started off as a really small number, and small is in value. So therefore, this number is going to be less than 1. And if I want to undo all of that, I got to move to the right 7 places. 1, 2, 3, 4, 5, 6, 7. Be filling in with lots of zeros here. 1, 2, 3, 4, 5, 6 zeros. 2, 3, 4, 5, 6 zeros. Here we have our final answer, our number rewritten in standard notation. Now that we've refreshed our memories on converting between the two forms and we've gotten comfortable with that, let's work on a couple operations with scientific notation. Number 10, we are asked to simplify and write each answer in scientific notation. 4 3/10 times 10 to the 3rd minus 3 1/10 times 10 to the 3rd. We are being asked to subtract. Whenever we are adding or subtracting in scientific notation, our rules are essentially the same. In order for us to add or subtract in scientific notation, they both need to have the same base 10 exponent. And in this case, they do. They both are 10 to the 3rd, meaning they are alike. They're like terms. Therefore, we can perform that subtraction. And all we really need to do is subtract our coefficients. So 4 3/10 minus 3 1/10. This is something that you need to do without a calculator. I'm going to demonstrate that by doing it here on the board. Remember, when you're adding and subtracting with decimal numbers, you line up those decimal points and then just subtract or add as normal. So 3 minus 1 is 2. Bring that decimal point straight down. 4 minus 3 is 1. 1 2/10. And then that 10 to the 3rd power, because it was the same, and we're just adding or subtracting within that same notation, nothing changes. And there we have our final answer. Number 11. Once again, we're being asked to simplify, but this time our operation is multiplication. And I know that because both of our numbers are written in parentheses, and when parentheses are used and they're side by side with each other or side by side with another number, that indicates multiplication. The rules for multiplication and division are a little bit different. You're going to multiply or divide your coefficient, and then you'll apply the properties of exponents to your base 10. Because of that, we don't need our base 10 exponents to be the same. So it is a-okay that our first number is 10 to the 4th and our second one is 10 to the 6th. So we'll go ahead, because this one's multiplication, and we will multiply our coefficients. 4 and 8/10 times 7. Once again, 4, 8, and 7, these numbers are all small enough that it is something that you need to either do in your head or work out on paper. When you are multiplying with decimals, you do not line up the decimal points. Instead, you put whichever number is longer, so has the most digits on top, and then the one with less digits on the bottom, as I've done here. 7 times 8 is 56. Carry the 5, bring down the 6. 7 times 4 is 28, plus 5 is 33. Once we have finished our multiplication, then we can look at our decimal place value. In our first number, we have 1 digit to the right of the decimal point. In our second one, we don't have any, meaning we need 1 number to the right of our decimal point in our final answer. So we have 33 and 6/10. Now for our base 10 exponents. Remember the properties of exponents that we just reviewed? Because we're multiplying here, we are going to add our exponents. 4 plus 6 is 10, giving us 10 to the 10th. Now, is this our final answer? No, it is not. If you didn't say no, think about why not. Why is 33 and 6/10 times 10 to the 10th not our final answer? Because it's not correctly written in scientific notation. In order for something to be correctly written in scientific notation, our coefficient here needs to be greater than or equal to 1 and less than 10. And 33 and 6/10 is definitely not less than 10. So we need to move our decimal point to make that happen. Well, if I move it to the right, it's going to make our number 336. That's not what I want. But if I move it 1 space to the left, if I add a decimal point movement, that gives us 3 and 36/100. Well, let's go ahead and do that. But remember that exponent in scientific notation only represents how many times you move your decimal point. Well, we just moved our decimal point an additional time, meaning we need to add that and track that movement, making it 10 to the 11th power. All right, we have one more example that we're going to go over, and then we'll close out this review video. All right, let's end us on a word problem. The population of the United States is 3 times 10 to the 8th. The population of the world is roughly 7 times 10 to the 9th. How many times larger is the world population than the US population? All right, let's reread that question again. How many times larger is the world population than the US population? So if we want to know how many times larger something is, then we need to perform that opposite operation. Because if I want to know how many times larger it is, division needs to occur so I can know, well, it's 5 times larger, it's 10 times larger. So I know for a fact that the operation we're going to do is division. But the important thing is to make sure we set up our division properly. So when we read the problem, we want to know how many times larger the world population is than the US population. The world population is going to come first. That's going to be our numerator. And then US population is going to be our denominator. So how many times larger is the world population than the US population? If I take the world population and divide it by the US population, I will get my answer. So now we can practice division. Very similar to multiplication, where we perform each operation separately. So first, we need to divide 7 by 3. These are small enough numbers that I do want you guys to practice that long division and work that out. So 7 is being divided by 3. Well, 3 can go into 7 how many times? Twice. So, and that the 2 times that it goes into that, 3 times 2 is 6. We have a remainder of 1. Well, we're not being asked to write this as a mixed number. When we think about scientific notation, it's either whole numbers or decimals. So we need to keep going. We add that decimal point in the 0, bring it on down. That gives us 10. How many times can 3 go into 10? Can go 3 times. 3 times 3 is 9, and we get a remainder of 1 again. Well, let's just do it one more time for good measure, even though I think I know what's going to happen. If I add another 0 and bring it down, we are left with 10 again. And 3 can go into 10 3 times. We're left with 9, another remainder of 1. That tells us that this is going to be a repeating decimal. So we can just write that with our little repeating hat, and we don't have to continue with the long division once we discover that pattern, and it's going to keep repeating. For the rest of our scientific notation portion, remember we follow our rules of exponents. So we have, oh no, I don't know what happened there, but we have 10 to the 9th being divided by 10 to the 8th. Subtract our exponents, and we have 10 to the 1st power. Therefore, the world population is approximately 2 3/10 times 10 to the 1st power greater than the US population. All right, that is the finished review for our Unit 1 number properties. Hopefully you guys are ready for your unit test or any other projects you may have following this. So go ahead and start on those, and good luck.